morning, gentlemen and ladies. I'm going to talk about high-yield bio-oil production from a carbohydrate-rich macroalgae employing supercritical ethanol as a solvent. My name is Hassan Zeb, and I'm from Green Energy Material and Process Lab from 성균관대 University. Okay, before I go to my contents, I'd like to talk about the most important thing in the research field, that is about the novelty of aroma. Okay, we all know that alcohol can do miracles, that it can make things happen which normally do not happen. But the main idea came from our friend Tom to use alcohol in a scientific work. We followed the footsteps and we got a bio-oil yield of 76% based on dry ash-free basis. But this only happens at 400 degrees centigrade and this much high pressure. The uniqueness of this work is this temperature and this pressure. We'll talk more about it later on. Okay, the contents of my presentation are like this. I'll very briefly talk about motivation and experimental work, and then I'll move on the results of my study, and then I'll discuss them in detail. And at the end, I'll conclude my study. Okay, the motivation to use algae is that although we have so many different kinds of biomasses, but the main reason to use macroalgae are these three. Number one is that we do not have to clear off crop feed to grow energy fields, so it doesn't possess any food versus fuel controversy. Number two is it has much better CO2 fixation because of its very high growth rate as compared to these terrestrial biomass. And number three, and the most important one is that it presents an efficient solution of the ecological waste disposal that usually come to the seashores and disturb the ecological life. Okay, once we have decided to use macroalgae, the next step is how do we use it? There are a couple of thermal liquefaction techniques that we can adopt, but we went on with thermochemical liquefaction, that is the use of some suitable solvent to liquefy our biomass. And the reason to choose some suitable solvent is that when we use some solvent, we do not need such a severe condition as in case of pyrolysis. We can conduct our reaction at quite milder conditions, and then even at milder conditions we get quite higher bio-oil yield as compared to pyrolysis. And then not only the yield, the oxygen contents of our bio-oil are quite decreased, and because of these decreased oxygen contents, we have quite higher heating value. Okay, just brief comments on the experimental work. When it comes to the choice of solvent, we have chosen ethanol as our solvent and the macroalgae as a biomass. We put ethanol and algae together in the reactor, and then as a product we get gas, bio-oil, and solid residue. And then all these three products went through these characterization techniques. Okay, let's talk about the most important part. How does temperature affects our product yields? Okay, you see, as we go on from 200 to 350 degrees centigrade, the yield of bio-oil steadily increases. And as expected, the yield of solid residue also decreases, and it reaches to its minimum value at 350 degrees centigrade. So the reason that I say the minimum value, because the inorganic contents of my macroalgae sample was almost about 20%. So it has already reached the minimum value. And when we go from 350 to 400 degrees centigrade, you can see that the solid residue yield, it does not decrease further. But the important thing is, bio-oil yield keeps on increasing. So there is something not from the biomass that is contributing to the bio-oil yield. What could it be? So we further investigated this, you can see that not only the bio-oil yield, but the properties also quite improved when we go from 350 to 400 degrees centigrade, from 250 to 350 degrees centigrade, higher heating value, energy efficiency, and carbon balance. You can see they improve slowly. But when we move from 350 to 400 degrees centigrade, there is a sharp increase in the properties of bio-oil. The most striking result here is the carbon balance. You can see from 350 to 400 degrees centigrade, the carbon balance is much higher than 100%, which indicates that there is some other source of carbon which is adding to our bio-oil. What could be the other source? It could only be ethanol, the solvent. To further investigate it, we compared two different solvents, that is ethanol and our normally conventional solvent, that is water. We use water at two different conditions, at supercritical state and at subcritical state. You can see here not only the bio-oil yield is very low in case of water as a solvent, but also the properties of bio-oil are quite inferior to what we got in case of supercritical ethanol. Okay, so to really establish that ethanol really reacts with our biomass and contribute to the bio-oil yield, we performed GCMS analysis. And when we saw the compounds that were having the ethyl groups attached to the molecules, in case of supercritical ethanol, the compounds having the area percent of the compounds that had ethyl groups associated with them, it was quite high as compared to supercritical water. So by this, it was established that ethanol does react with macroalgae biomass, and it is contributed to the bio-oil yield. But the important thing here is it does not happen at until 350 degrees centigrade. So the unique thing in this study is that we went on from 350 degrees centigrade up to 400 degrees centigrade, and at 400 degrees centigrade, all this miracle with ethanol happened. Okay, very briefly, you can see from 350 to 400 degrees centigrade, the component which is expected to come from ethanol is mainly hydrogen. So the yield of hydrogen is quite improved, and the oxygen to carbon ratio is also from 4.4 to 0.5. It suddenly decreases. Okay, effect of time. Very briefly again. From 0 to 45 minutes, the yield of bio-oil decreases, and then from 45 to 60 minutes, it kind of stabilizes there. And the reason for this is the gas yield, it suddenly increases. And the properties of bio-oil also improve until 45 minutes. But as we go to 60 minutes, the properties of bio-oil also suddenly start increasing. So we decided that 45 minutes was our optimum residence time. Okay, the conclusion. Highest yield of bio-oil from all previous studies based on ethanol and macroalgae. In this study we got the highest yield, but it was obtained at 400 degrees centigrade at this much high pressure. And it was established through the carbon balance and through the GCMS results when it is compared with the supercritical water that ethanol does react with the macroalgae. And third one is the efficiency, energy efficiency higher than 100%. It indicates that the process is energetically favorable, although we are using very high temperature. Thank you so much for your attention.